You are listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining, and this week I'm very happy to welcome Michael Gimbel. Welcome, Michael.
Hey, how's it going?
It's going great. How about you?
Pretty good. We had a power outage and some other hectic stuff today when we were already behind, so but we're catching up.
Oh, yeah. I definitely feel the end of year crunch as well. So for anybody who doesn't know who you are and what you do and what your company does, please give us all the details.
So, I mean, anybody in kind of the podcast, Instagram realm may have heard of us. You know, we've advertised very aggressively. We had two companies. The primary one that we advertise is Gimbel Automation. And basically that started out with the premise that why are we potentially spending like 100, 200 grand on robot integration systems when you have a robot right there, which is the CNC machine, right? It already has motion. It already has the ability to accept G code. So why integrate it with something? And basically, the long story short is we ended up developing spindle grippers that worked without through spindle air coolant for our own use, for our own internal production. And we ended up rolling those out with some of our consulting clients on a couple kind of one-time large jobs. And then we basically chose to make that a entirely separate business unit. So now we have spindle grippers, vices, rotary unions, solenoid kits, and then something that we're just getting into now to really start to sell to the broader market is conveyor loading systems, which are these big like conveyors that go in advance into a 5-axis machine to let it load itself. And then we're also doing a lot more turnkeys now. So we'll do the whole programming setup thing to where we can either just come in or we do what's called a semi-turnkey where the customer tells us what the part is and then we set it up on our machines, get it running, and then ship them all the stuff.
Awesome. That's super cool.
And then we do have another business unit that's actually, I would say, 3/4 of our revenue, which we call Gimbel Manufacturing. And we pretty much do engineering consulting there. So it's industrial product design. It's like 5-6 figure multi-month projects where we kind of charge up front like a law firm on a retainer basis. And we do like complicated things. So we're doing like oil field tool development. We do art and architecture, a little bit of high-end contract manufacturing. But as a general rule of thumb, kind of say like if it doesn't have some engineering involved, the only contract manufacturing we do is like really specific niche specialty stuff that like most shops don't want to figure out.
That's super cool. So let's get into your backstory then. How did you get to where you are now?
Complicated. So, 25, so I'm younger than a lot of shop owners. And basically, I mean, as far as like manufacturing, I've kind of always been in it as long as I remember. Like I would come home from middle school and I would just put on How It's Made. Like the Science Channel would have like just How It's Made for like hours at a time. And I would sit there in front of the TV for like 3 or 4 hours. And I really love to make stuff. And I would try to convince my parents, starting from when I was like 8 or 9, that the thing they should buy me for like Christmas or my birthday or whatever was like a table saw or a bandsaw, and I had to try to convince them that it wasn't super dangerous, which it definitely was. So I got them to like gradually buy me like an entire woodworking shop, which, shout out mom and dad for that. So, first they bought like a drill press and then a bandsaw. And, eventually by the time I was, getting out of high school, I had like a CNC machines, an Epilog laser cutter and all kinds of stuff. That was very gradually built up over like a decade. So that was kind of the beginning. I was kind of always obsessed with it. From there, towards the end of high school, I got really into the whole like college thing, started trying to play the college game of having like the best GPA and being, in all the clubs. And, I exhausted myself and I ended up graduating like valedictorian and the president of a bunch of clubs, but I like barely slept and wasn't super happy and I was still doing robotics and engineering, but I wasn't doing a lot of the really cool manufacturing stuff that I had done earlier. And basically when I got into college, I had went to some fancy school and I basically saw like this huge decrease in what machine tools I could play with. So, when I was in high school, I had this whole like woodworking shop, like a CO2 laser cutter, all this stuff just in my garage. And I was also like an intern at this biomedical lab that was making prosthetic arms. So I was running one of those like big $1 million EOS metal 3D printers. And then, I got to a fancy college spending like 75 grand a year on it. And I just wasn't happy, like just had all the tools taken away. And I remember I tried to get like self-study. I tried to let them get me to work in the machine shop and just nothing really worked out. So I ended up, dropping out of school and actually convinced a couple professors that it would be a good idea to give me like $70,000 to start up a little startup company. And
That's awesome.
yeah, that basically ate up probably the next 2 years of my life. I did the whole venture backed startup kind of like wild, crazy thing. And I did it when I was like 19 to 21. So we raised like a little over $1 million and got a warehouse and bought, first Hoss and a bunch of a water jet, a bunch of different stuff. And from there, ran that company like honestly really badly. Like I was 19, I had no idea what I was doing. And 18 months down the road, the company ended up failing. And a long, very convoluted series of events later, I kind of ended up with my own prototyping shop where it was just me, a bunch of machines, and a bunch of debt to work off. So from there, that's kind of when I started Gimbel Group, which was, really just let me figure out how to make a business work and work myself out of, all this debt and figure it out. And we started doing contract manufacturing, a little bit of engineering consulting, and really started out trying to sell like products, machine parts to startups, because those are the people I knew kind of in the local Los Angeles startup scene. And over time, we moved more and more out of the startup space because obviously they kind of fail on a 2-year cycle, so they're not the best customers, and more into engineering consulting. And the company grew really quickly, and COVID hit, and then we lost all of our consulting clients. And that was really tough. But then we kind of gradually moved back into contract manufacturing. Things started to come back. We moved back into engineering consulting. And then probably over the last year, that's when we really started developing the Gimbel Automation stuff. And I think we took it really seriously for the last 6 months to where it's become like a quarter of our overall revenue and really is like the long-term goal for the company.
That's super cool. So before we go into some more of the current stuff, you touched on a lot of very exciting things and glossed over them real quick. So let's go back first. This biotech company that you worked at, how did you get them to trust you at 17, 18 with $1 million metal 3D printer?
Yeah.
How did that whole work out?
So yeah, that was its own story. So I was in a bunch of clubs and doing the whole trying to build out my resume for the fancy school thing. Cause I had this idea that if I just go to a really great school, I go for mechanical engineering, everyone's going to love machine tools. And it turns out machinists are much more of the actual community that I was thinking of in my head there. But regardless, I was in this engineering thing from middle school through high school. It was called Mesa. And they had it was an engineering contest and we had to build a prosthetic arm. And my freshman year of high school, we ended up, winning the whole national thing. And one of the local Colorado judges, because I lived in Denver at the time, was this guy who ran a biomedical lab at the children's hospital. And he basically let me work for free as an intern. And, they gave me a copy of SolidWorks and I was like, this is amazing. And I just threw myself into it. And then, I was also on the robotics team. So all of our robots were then designed in SolidWorks, and we would go home and laser cut them at, after school at my house. And I just really threw myself into it. And basically they ended up, it was a kind of a difficult time there. And hopefully one of my old direct bosses isn't watching this, but basically the guy ended up liking me enough that he essentially gave me my direct boss's master's project to rework, which was this little prosthetic arm joint, which caused a lot of direct tension with my direct boss. But
only imagine.
Yeah. So that was actually me kind of getting shoved off onto the metal 3D printer as a way for something else for me to do. But actually running the machine, wasn't that difficult. It was more that those old EOS machines, they were so slow, they were so expensive. And then every, I swear, 12 hours, the recoder blade would get stuck on the metal part because it had warped. And you would have to shimmy it was a whole thing, a whole reset cycle. And then once you would reset it, then you'd get a bunch of a line all the way through the entire cross section of that in the print.
Oh, geez. So, and then your startup was also metal 3D printing based, right?
Yeah. So we were doing, metal 3D printing has always kind of been a background obsession of mine. I actually spent probably a year ago, we spent close to 300 grand developing our own metal 3D printing system, because I had the idea that it would be better than buying a desktop metal or a Mark IV system. I was very wrong. That was not time or money well spent. But the what happened with the 3D printing company is initially I had this like idea. I don't want to like go too into detail in case the that IP ever ends up getting sold off or whatever, because now that company's gone, I don't no longer really own any of it. But I had proven out a concept to make a SLA 3D printer have like soluble support. So like if you imagine like a Formlabs printer, you could like break off the support structures like nothing. There would be no mark, no post processing. And then I have kind of a tendency of like letting things kind of spiral on themselves and build up. So I had the bright idea of like, SLA with no supports isn't enough. We should turn this into a metal 3D printing thing, because we can go and take this system, add a big robot to it, put an entire investment casting system around it, and automate investment casting of like aluminum or whatever, and make an automated workflow for 3D printing of components. In 2020 hindsight rather, I kind of see now my ambition was kind of what got the best of me there, because we just didn't have enough money to do what I was trying to do. But that was something that was really cool. It was a really unique time in my life that now that I'm a little bit older, a little more sane, a little less naive, I'm glad I'm running a different type of business. I'll say that.
For sure. Any other lessons learned? I mean, I think that I've said it before on the show, like we learn much more from failure than we do from success. So like, what can you tell us about insane growth and funding and how, to avoid the pitfalls?
I mean, I would say it really depends on like the type of company you want to be and the kind of life you want to live. Like, that point in my life, I literally lived in my office, and like all the people involved in the company loved it. They're like, he's so dedicated, blah, blah, blah. I worked 100-hour weeks. I slept like 4 hours a day. Now that I look at that with like a stable life, I kind of go, like, what were you doing there? Why did no one tell me, like this, 19-year-old kid, like, what the hell are you doing? But so, the first thing I would say is like, make sure you really want it. And then the second thing I would say is, make sure you know the consequences of taking outside money, because like the minute you do that, it's not really yours. And what I love about running a company that, I have the final say on is I can make decisions and I kind of live or die by them. I don't have these like outside influences that might be driving things in a way that I don't think makes sense. So I think if you're going to take outside money, need to know how to manage the people. And you also need to be able to have a business model that is going to be able to have just a sliver of a chance for that like outsized result.
Okay. Yeah, I like that. I think we can all see that in a lot of these companies. Every single venture-backed company has to have something AI based at this point. And like you just see it like roll out across the internet. You're like, oh, do you really need an AI based tool for that? No, but you must have venture behind you. Like,
yeah.
Well, then let's get into how you developed the spindle grippers and, where that came from, where you got the inspiration from, and then, how the process was to bring that product to market.
Yeah. So, that kind of came directly after our metal 3D printing failure. So depending on how I slice it, like I've looked at the numbers, it's like I spent, I'll say even wasted, like, a good 3 or 4 months somewhere. You could count for labor, somewhere between like $300,000 and $400,000 of, like profit that we had earned basically, and poured it into this endeavor of like building a metal 3D printer. And it was like an FDM style printer. It's really cool. We still have it, it did everything. And again, I think I kind of let my ambition get the best of me. We added a vacuum plate work holding. There's an entire Aroa style robot that goes and loads and unloads the build plates, which is just totally unnecessary. It has tool changing, so it can tool change to a CNC milling head to then get a better surface finish. And so we spent all this time and effort getting this printer like as close to perfect as we can, while still trying to keep our like existing consulting clients happy at that time. And then at the very end of it, we figured out the sintering process, which turned out to be really hard. And we had these big Chinese sintering furnaces we got from, Alibaba for like $50,000 and, shipped across the ocean, custom built. And then we get that whole workflow to work. And then I go to our customers and I try to sell it, and no one wants to buy the parts. So it turns out like they're just, first off, it's not the same market that we're selling to. So we try to penetrate a different market. And then we realized like at the end of the day, the price point of the parts really makes them only good for like quick prototypes. But the problem ended up being that like, I think because there's just a market education problem there, really, of, a lot of engineers just want to prototype with the aluminum that they're going to, the billet that they're going to machine the final part out of. So, at the end of the day, became a business decision where I just realized and had to reconcile with the fact, like, this was a really dumb business decision. Like, we did something really cool. And then I kind of had to ponder, like, what's the next thing? Because I knew I wanted to eventually transition at least a good portion of our business out of engineering consulting, because it's, very cyclic revenue, very big projects. You lose a couple clients and you have to scramble to find more. I wanted kind of some stable backing that we could eventually, either the whole company becomes that, or at least is a good starting place. And I have always had this tendency to, like, create cool things that I thought were neat or useful, or just build stuff that I thought was overpriced. So, over the years, we built like a hydraulic system to open and close a Kurt vise so we could automate that. We built our own shrink fit machine for, like, shrink fitting holders, which is, again, another horrible thing. We should have just bought it. we built our own 4th axis rotary and then ended up buying one anyways, because it turns out Haas has that pretty figured out.
Oh, no.
We had all these things and went and looked, like, all the, like, 25 complete or mostly complete projects that had just been sitting there that I just built because I wanted to. And I was like, well, what actually has, like, a known market that we think the competition is weak? And we came up with a spindle gripper. Like, we had the spindle gripper, we built it, we used it literally once for one job, and that was integrated with the Kurt vise. And I looked at it and I'm like, there's all these problems with the current spindle grippers. Like, there's really 2 manufacturers that were building spindle grippers at the time. And they're both really expensive. You have to make their own fingers. You have this super weird, like, 6 degree of freedom flex block to make it work. They only worked through air or through coolant. So we just started, and basically we invented and started the patent process on what we call a bypass air gripper. So basically it has a little stub with a hole in it that goes and seats into a thing a little block that sits on the bottom of the spindle face, which just bolts down there. And it lets a machine through air or through coolant grab parts. And we built it really first for ourselves because we had this VF2 YT that didn't have through air coolant, and there was no way to automate the parts the way we wanted. So we built it for ourselves first, then took about a month and iterated it a whole bunch, and then kind of soft launched it as a product. And then that we kind of just have kept things rolling from there. We added, air vices, instant solenoid kits, which basically just plug and play and give you a couple solenoids for your machine. And now we're going all the way up through, our conveyor loading system is now the big thing we're pushing, as well as these kind of turnkeys, semi-turnkeys, where we're not just delivering you like a vise or a gripper, but we're giving you a solution to the problem, which is, how do I make 1,000 of this part in my facility?
Very cool. Well, so on the subject of your spindle grippers and everything, Random Fabrication and Firmworks, Joe at Random asked, where is all your stuff made? And Firmworks asked, talk to us about the air vise. Are they manufactured in-house? So yeah, the full gamut, where does everything come from?
So yeah, we get asked that a lot. I'm very open about it. We don't make the vise. You may notice that vise is weirdly similar to the Haas one. I'll say we buy them at very high quantities from a contract manufacturer. And really we sell those as a way to kind of fill out our lineup, because, we've really moved towards trying to deliver solutions as opposed to delivering just like one piece in the puzzle. And the air vise there is kind of one of those pieces that we can deliver with the rest. So, our margins are thinner on the air vise than any of our other products, even though that's the one thing that we don't really make in-house. We make a lot of our things have parts that go into them, right? So, some of our things we, use like SMC air components or other brands of pneumatic actuators or linear rails, right? That stuff is going to come from all over the world, whether it's Germany or Switzerland or Taiwan or China. We're not going to make an individual motor. But like, if you look at our automatic tumble basket or our instant solenoid kits or the grippers, any machine part there, that's pretty much all us.
That's super cool.
Yeah.
That's quite a few parts too, I would imagine. So
yeah,
how much of your own systems are you using to produce those?
Yeah, so we have like 55, 60 SKUs now. And, we've only been selling since like mid-August on e-commerce. So it's a ton of different SKUs. And really the the trick to managing that has been that we've built our own kind of mini ERP system. We use I don't know if you've used Notion before. It's like a note-taking thing. And it's like $12 a user, but we have like databases built out. We have work orders scheduled within projects. And that's kind of the number one thing that has really taken everything to the next level and helped us scale and manage it all. But, as far as like how we actually make so many different products, unfortunately, like you always have this question of like lean versus batching. And to be honest, I love the idea of lean. I love the idea of single piece flow, but because of the quantities that we run and how many different part numbers, we end up batching a lot. So really the secret to how we manage so many things is we batch them, we run them on the gripper system, 100% of the gripper parts and whatever. Anything that can go and be loaded by a gripper is loaded by a gripper. And almost all of those now run on one machine. So they almost all run on our UMC 500, which has a conveyor loading system on it. And literally we load up, say, 50 blocks, and we just program that to loop until it doesn't have any material there anymore. So, and the way that those are built, an operator can just literally walk up and add another row of blocks, and the machine will just keep going until it stops. So, we try to manage our inventory on the front end, check the first part and make sure the first part is good. And then we just let the machine run. And then we'll make say like 50 or 100 parts worth of spindle grippers. And then they get sent off to anodized, QC'd, and inventoried. And then they just kind of gradually deplete, and we rinse and repeat that process with just a bunch of different parts. Obviously, it depends on what it is. Like a lot of our parts have to get water jet. Some go to the gantry mill, some get powder coated, some get anodized. But it really depends. But really, everything starts with that ERP system, and then we batch wherever we can, and we try to machine all the parts in single piece flow. So we'll like integrate a part flipper into our system to where even on like a 5-axis part, for instance, we machine it like 5-axis, but then we physically flip the part inside with a spindle gripper, remove all the like top hat style material, and then unload a completely finished part that the only processing it needs is like maybe a bead blast and anodize.
Super cool. So you've mentioned a few machines. What does the machinery at your company look like?
So yeah, most of it's pretty new. We're a Haas shop, which has its ups and downs. I consider them like the Honda Civic of CNC machines. Like they will get you there. They're not going to go 0 to 60 super fast, but they're super affordable and reasonably reliable. So we have a water jet, like a 5-axis water jet with pretty much every single option, 5 by 10 foot bed. We have a gantry mill that's 5 by 10 feet, which Haas calls it a gantry router. And in reality, it's somewhere between a router and a mill. So like you can cut stainless, but not fast. Then we have a VF2 kind of standard machine with the 4th axis on it and a bunch of automation. And then last year we bought brand new UMC 500 that we just got like a killer deal on. And then tons and tons of random stuff. Like we have like 15 3D printers. We have like a laser welder, all really is like a prototyping paradise. And that's really coming from me just like loving building stuff. And then now that the business is really scaling, I'm trying to kind of, bring in a little bit of reality, focus on profitability, grow the company, but, still kind of keep that manufacturing, engineering, just, for the fun of it, ethos there.
Yeah, I would imagine. I mean, you want to keep yourself interested. Like,
Yeah.
At the end of the day, you still want to be happy going to work. So it makes total sense. Let's talk about coding all of this and all of that. Possum Solutions asked, what's the lowest quantity that makes sense for spindle grippers? And then writing code that uses probes and other methods to make overnight running work well. And the Sunshine Coast Makerspace, how do you work out the payback on small jobs, the extra programming burden and setup that comes with the cost? And AM Metals was also asking about spindle gripping through CAM, doesn't want to do the hand coding. So let's talk about the software side of this hardware.
So that's one thing like everybody thinks is going to be really hard. And we got that feedback really early on. So, a lot of people wonder like, how do you have so many SKUs so fast? And basically the answer there is just listening to our customers and seeing what they have problems with. And the very first problem we saw is nobody knows how to program these things, right? It's a little bit complicated. If you listen to podcasts, like a lot of machining podcasts like I do, there's a couple guys running grippers and you always hear them talking about like how difficult it is to do the gripper programming. So the very first thing we did when we had like the gripper and the vise as a product is we wrote an entire automatic program generator. So if you go onto our website, you go on spindle grippers and you do the drop down, you click on automatic program generator. And basically you just code a single part. And then you take that single part code, post it out of Fusion or Mastercam or whatever. You paste it into the insert machining code here after you delete out the M30. You tell it the spacing for XY, and you hit generate, and it generates the code, and you give that to your machine. So basically the answer is like, we solved that problem already, but that's, one thing that we need to do a better job of, like actually showing people, like, this is where you go, and this is how you handle that. The other thing with like the conveyor loading system, it's even easier because you're literally grabbing the same component from the same location every time, putting it into the same vise every time, unloading it with a gripper every time, putting it back in the same return location every time, because those conveyors can move in and out and are advancing the feedstock. So with those, it literally is just a loop that you go through for the number of parts that you want to manufacture. So the programming is really easy. And I encourage anybody just to give us a call. We'll walk you through how to use it. Most of the time, even with like a basic gripper vice package, we'll help you actually get the first one up and running. But the programming itself is so much simpler than people would think. The kind of quick summary of how it works with just like a single lot part with a spindle gripper and vise is you grab a spindle gripper. Ideally, if you have a vise, a spindle gripper, and you bought like the instant solenoid kit with a little control pendant, that little package is enough to get up and going really easily. And basically, you put one of your pieces of stock into the spindle gripper. With a little manual control pendant, you turn it on so it's clamping. And then you probe it as a tool. So with your Renishaw tool height offset or whatever you're using, you probe it as a tool, and that's going to get your total gripper height. Then the next thing that you probe is on your gripper tray, the bottom left pocket, probe the Z, and that's going to be, in this case, like the simple example, your G55 Z height. And then the center X and the center Y in that pocket should be G55 X0 Y0. And then essentially you do the same thing in the part location where you want to actually machine the part on the vise. That should be G54 X0 Y0, with the Z0 being on the face or the parallels or whatever you're actually machining on for the bottom face. And what that lets the program do is basically, if it goes to G55 X0 Y0, then goes down to Z0 and then clamps, now it has the part in this perfect location. Then it can go back to the full machine height, go to G54 Z0, or sorry, X0 Y0 rather, then go to G54 Z0, drop it, and then clamp the vise, and now that part is retrieved. And then you just do the opposite in order to drop that part off. So, if that sounds like gibberish for anybody listening, basically all you need to understand is you just have to put it in the program generator, it'll do it for you. And the program generator will increment everything all the way through. As far as the other question of, when does it make sense? I think that really comes down to how much time and energy you have to put into the tray. So, because you can just probe these couple of locations, it really is super fast to get going. It probably takes like an extra 2 minutes versus running a normal job setup, because you're just probing two more things. You're probing the tool height and then the first stock location on your XY grid. And then it's going to come down to, how are you holding your parts grid? Is it on a 0-point system? Is it just bolted to the table? Are you going to have to dial it in? And then, are you machining it, or are you doing something else? So, obviously you can just, if you have a CNC machine, you can machine the pockets. But, most people who are running small production runs or a lot of variety will actually 3D print them or water jet them or laser cut them. And it works just as well. Typically, we recommend like 15 thou total tolerance. And from there, you're able to really quickly make one of these trays and just get up and going.
Okay. So how do you guys run it? Before you got the UMC, I assume this was all on the VF2.
Yeah. So
how were you guys running it?
So 0-point systems are awesome. That said, like we're big fans of part tending versus pallet tending. If you're pallet tending, you see these pallet changing machines, they're hundreds of thousands of dollars, they're massive. And the thing about part tending versus that is you can tend parts in a very small configuration and run a lot of them, because your part is always going to be smaller than the pallet it's on. So we're big fans of part tending versus pallet tending for automated solutions, which, should be obvious by basically all the products we sell. And obviously take that with a grain of salt, because that's the type of stuff we make. But that said, we still love 0 points. And we've tried all of them. We've tried Chunk, we've tried Pearson, we've tried a whole bunch of 0 points, but the ones we really fell in love with are the Aroa ITS system. So we have Aroa ITS on top of Saunders plates wherever we can. And basically what that lets us do is whether it's a vise, whether it's a gripper tray, whatever, it goes on that 0 point. And for us internally, if we are using a gripper tray, which to be honest, we don't anymore because we've mostly moved to the conveyor loading system because it's just so easy to set up. But if we are using a gripper tray, we always just will water jet out a profile and bolt it onto basically a pre-built ITS Aroa pallet. So the setup is so incredibly fast. Now that said, internally now that we've built the first few units of the conveyor loading system, that thing is so easy to set up. It's almost like a woodworking tool. So, it has 2 different fences that basically you use to center your row of parts in the conveyor. And then it has another fence that you use to set the return pathway. And in the center, it's a conveyor belt that basically will turn on every cycle to advance that row of parts. And then they just start slipping once they hit like the backstop fence. That whole conveyor with the unloading tray as well advances into the machine, grabs the component, the conveyor pushes the next component over, you load the part into the machine, you move that whole system out, you machine the component, and then you run that process basically in reverse, grabbing the finished part from the vise, putting it into the return tray, and then from there you just rinse and repeat. So like the programming there, you're literally undoing a couple of knobs. You're still probing 3 different locations. So you'll have your G54 for your vise, your G55 for your part feed, and your G55 for your part return. But from there, it's literally just a loop. So we can set that machine up now that we have SOPs written out for it in like 3 minutes. So we've had parts where we have like two units, and we'll still run it on that setup with the conveyor loading system, just because like we have it down and it's so fast to set up. Whereas like gripper tray, we still have to generate another work order, cut out the profile on the water jet, bolt it to an ITS pallet. There's just more steps involved.
That's super cool. So speaking of 0 points, Kinetic MX was asking about part loading versus fixture loading. They do a lot of high mix, low volume parts and have good luck working with a 96. Do you have any plans of developing products or solutions towards that type of automation?
So the answer is yes, but I'm not super sure on the timeline. So like, I mentioned earlier that we built out this whole metal 3D printing system, and on the side of it was this Aroa robot. And, so we basically built before a pallet loading solution. So, the very first thing that our philosophy on automation is like, it has to be compact, it has to make sense, and it shouldn't be bigger than the machine. It just shouldn't. It doesn't need to be as rigid. There's really no excuse for these massive, the Haas APL comes to mind, the Matsuura pallet changers, like all of these just huge machines that don't even have like that great of part weight. And when I think of a good machine for part loading, my mind immediately jumps to like the Aroa system, where they have this kind of rotary style polar coordinates robot that's doing loading and unloading. And, initially when we were doing the metal 3D printing system, I was like, we got to buy one of these. We were at IMTS and I talked to them and they're like, oh yeah, 250 minimum, like 250 grand to buy a system. And our lead time's currently out at 2.5 years. So I was like, okay, well that's out. So we ended up basically building something similar with, some different stuff that went on this metal 3D printing system. It works brilliantly. It's very compact. And, we actually started the process there of trying to, successfully designing everything, and we still have to manufacture the first couple of prototypes and get it into beta testing. So like that's something that I expect to come, but I think it's probably a year away. Because just from like a business philosophy, I've really been learning to force myself to be more disciplined, to go after the thing where I know like we can go sell them, we can get a win, we can see revenue growth, we can grow the team, grow the business, and focus on growing the business as an avenue to like achieve my goals and ideas, rather than just kind of jumping the chase there, doing something before the revenue is supported, before it's proven out, kind of like we did with this whole metal 3D printing project.
Totally. Yeah. So then in that vein, where did the conveyor come from? Was that like a customer request or something you had been cooking on for a while? How did that come to be?
So just brainstorming, really. So, I mean, we have a ton of stuff that has come from not even really customer requests, more customer complaints or like, how do I do this? Like, we had a ton of complaints. So like we would get people calling and it was just, how do I wire up a solenoid? what's the difference between a 3-channel and a 5-channel solenoid? All these things. How do I wire this to my Haas? And we would have these support calls. Eventually, we wrote a whole article on how to do it, and we kept getting them. And that's where the instant solenoid kit came from. It's like, okay, well, we can refer you to the article. We can help you for like 10 minutes, but you need more help than that. Like, we have a product that just does the thing. And there's other stuff like that. So, we developed vice bases that basically drop in work with all the Haas Air Vice Ready provision kits. We developed rotary unions that go on Brother or Haas or a variety of different machines. It's just kind of drop in things as, solutions to problems from our customers. But the conveyor loading system was more just me wondering, like, how do we make this work on this, nice shiny machine? We do a lot of very small, like, one-off parts for the consulting side of our business, where it might literally be run once and then thrown away because it didn't function the way it was supposed to. And then on the other side of things, we do a lot of production where someone was, sitting there running the same part for, the Gimbel Automation spindle grippers or something like that. So what we came to was just brainstorming with me and my team of, like, how do we make this work? And we had a bunch of different ideas, and the concept of, like, well, what if we could have, like, the gripper tray just go into the machine? or what if we could, and basically that kind of morphed into, well, what if there was like a conveyor belt going in and a conveyor belt going out? And then that all went to, like, we started just building one. We simplified it to just be a single conveyor in, because it turns out that the parts can unload in such a way to kind of push a train of parts on the reverse using the machine's motion itself. And there's a whole process that, like, we can't even show on Instagram because of just the way, like, the US patent system works is, we have to go and get a provisional in before we can even show the first hint of what's going on. So we started that, a couple months back, and then we, built the first one, started tweaking it, started testing it. And, now that we're actually starting to push them as a product, the next step up is that we're really focused on getting really complete PLC integration, full light curtains, and a complete solution that can go, in any shop, regardless of whether they're, under ISO or whatever kind of certs they need, getting all those, like, safety factors in place and making the thing as robust as it possibly can be.
Okay. Yeah. So how do you guys deal with probing and all of this? Like, how much do you use probing? Are you using it for part detection or no? Like, because you had mentioned that, the conveyor will go until it runs out of material. Are you actually physically looking for material, or is it just like, well, if the device is empty, the device is empty and it's not a big deal?
So, on the PLC variant of the CLS, it has an inductive sensor that'll just error out at the point that you've run out of material. So you can set it to just infinitely loop, and then it'll throw an error, and then it'll talk, in our case, to the Haas MFIN and say, oh, you gotta stop. And in the case of, like, the base unit, the very base unit is, like, its preliminary pricing is like 13 grand. So just that unit is designed to be tied in to just, like, the M codes directly. So you just need a few M codes to run it, like, I think 3 or 4, and some sort of side mounted auto door, and you can get the system running. But as far as part probing on the conveyor goes, that thing is incredibly repeatable in terms of where it goes to. It always stops at the same location. It has to be weighted and secured to the ground properly so that it's, reasonably precise. But the probing is really an initial setup thing. And then when you're doing probing, it really depends on what you're trying to achieve. So, we have some customers where, like, the precision of the part is just really, really, really intense and difficult to get to. And that's where, like, probing really makes a lot of sense. Is you load your part, especially say it's like a second operation, you can go and probe, like, the XY location of the component and do, like, a temporary G54 XY offset shift. And you can even do the same thing with the Z to make sure that, it's fully seated, which honestly, if you're running the system properly with the ship fan in between cycles, it shouldn't be an issue. But if you're doing that, that's where probing makes a ton of sense. And probing also, can just be an extra safety feature before you've proven a program out. But, internally, honestly, like, we're so familiar with the gripper systems that we don't really probe it. If we're running overnight, we'll sometimes put on, like, Haas safe mode. And to be honest, we have run probably 20, 30,000 parts through gripper systems. And every single error has always been a user generated problem. It's never been like the vice failed or the solenoid failed, or it was like, oh, for instance, one time I was doing a setup and I had I had stopped the setup and started it again, and there was already a part in the vise that it tried to load onto, and then it, Z axis servo overload error, right? The almost all the errors have been due to user error, and once you figured it out, it's super reliable. It's just, figuring it out that first time, which we've done our best to make as easy as possible.
Okay. Yeah, that makes total sense. Let's see. Brian Willman said, best ways to get completed parts out of the machine cabinet to a conveyor, shaker, degreaser bucket, what have you. I mean, It sounds like the conveyor is a pretty good solution, but anything else you guys use?
So I mean, the conveyor, like right now, it's really geared at 5-axis machines. And the reason being is that because the conveyor only has one axis of movement, the goal is to basically get the ability for the 5-axis mill, which usually will typically have like an XYZ moving head, to be able to get that XYZ moving head in a range to where it can pick up a part. We're in the process of retrofitting our RVF2 to be on a similar system, but because the table is the thing that's moving instead of the head in the XY coordinates, it's a little bit more complicated. So generally what we've done there is like we have a part flipper. The part flipper is like a little intermediary grabber, which also then allows you to do multiple ops in a single cycle, retrofit it in that kind of a scenario. But, the answer is like you're trying to do it specifically on a, 3-4 axis machine. There's a lot of creative solutions we've seen people use. The easiest and the way that we've written the kind of base version of the automatic program generator to work is just to machine a part, grab the stock, machine the part, grab the finished machine part, and just put it back in its first location, right? So it just goes back to the same place. And then it's just a matter of, blowing it off and so on. But, over the course of doing more and more turnkeys, what we've started to see is like, especially tiny parts, really tiny parts, knife parts, if any firearms parts, that kind of thing. If they're really small pieces, it often makes sense to have like just a bucket that you let fill with coolant, and every single part just gets dropped in there. The coolant or the fluid there basically prevents the parts from digging into each other. And there's other cool things I've seen people do. Like, for instance, if you're willing to make the modifications to your machine or to prop the door open and make a little shield, you can use a PVC pipe kind of coming out the side and basically make it just like a Williman, to where on the finished operation, it's going into its own area. So we've seen it all. The simplest thing that's kind of pre-built for our users is return it back to the same place. Or in the case of the conveyor loading system, it carries it out of the machine on its own. And in that system, typically, almost everyone who goes for it will get the air knife to clean off the parts in the conveyor on the travel out. But in other cases, like, you can definitely get creative. You can spend just, $3-4 with us, get an air vise, a spindle gripper or two, and a solenoid kit, and you can automate the stuff on your own, especially if you're savvy with G code and willing to make something work.
Yeah, that's super cool. Let's see. AM Metal said also asked about adjusting the torque of an air vise to, small plastic parts or things like that. Like, how do you deal with, a product that's not yours and having to become the point of contact for that, and then also how adjustable are those things?
So yeah, I'll push back a little bit saying, it's not our product. Obviously we don't make it. It's a standard thing that we buy in very large discounted batches that we make a small amount of money on. And there are elements that we do change. So every single vise that comes in, we take the time to QC it. We take the time to laser etch our logo on it. We make sure it's not actually torque, it's just a linear force value. We make sure all those numbers are within spec. And then on a lot of vices, like half of them that go out, they also get these rotary union adapter plates that let you run it with a rotary union or with another kind of system. And then we install, inspect, and test those. So, there is still work and overhead and time that goes into the QC process, little things you don't think about, like, how do you actually ship this volume of stuff from Taiwan? How do you pay for the customs fees? How do you make sure it shows up, right? Like the brokerage and the effort, and then the QC dealing with rejects. There's actually a lot there, even though, we don't technically manufacture or even design the base product. But, on top of that, the answer to, why we didn't go and make our own air vise is like, these things are just really good. There's no way for what we sell them for we could even make them, given that they're all steel, they're all stainless. And the big differentiator for this particular vise compared to really the air vise or shunk or any other solution is that this is the only like compact air vise that has the ability to move in and out for the first operation of the hard jaws. Everything else you have to basically buy a fresh set of soft jaws for every single operation. Whereas this, if you're doing a first stop, if you're doing a 5-axis part, you just go with the serrated hard jaws and continue. So, I'll say that like, it's just a really good product. We don't make a ton of money on them, and we sell a ton of them because, we're number one, a source to buy them. We always have them in stock. We QC them. And the big thing too is with all of our products is we warranty everything for 30 days. And it's kind of as long as you didn't crash it. and I've definitely seen some return claims that they did crash it and we just process it. Right. And that's one thing is we really just stand behind all of our products, like our automatic tumble baskets. We just sell tons and tons of those. It's like a couple a day. And sometimes people they'll put them in vapor honing cabinets. I've seen wires cut and soldered back the wrong way. Stuff happens. People mess them up, and we just ship them a new one. So, it's also just having a local US company that is going to, back the thing. Then, as far as getting into the actual question, sorry, hopefully I didn't get too defensive there.
No, not at all. But so is the force adjustable, and how low can it go to where it's just not even gripping anymore? Yeah.
So they're a little weird that way. So they have spring retention. So like a base, I would have to pull up the spec sheet, but I think from the top of my head, like the 100 mm air vise has something like 700 newtons of gripping force when it's just kind of doing nothing. So it's kind of like the Pearson pallets that way, where there's just a spring and it's already clamped. It's different from something like the Pearson pallets or things in that normally closed state, in that then there's additional air port that stacks on top of that force. So anywhere above that like 700 Newton threshold, you can clamp above it just up to like, I don't know, 3,500 pounds or some ridiculous number. And then for the release, obviously you need a separate airline there. So, you have two different lines because they're connected. They can be controlled with a single M code with a single 5-channel solenoid. And if you are buying our stuff and you don't know what I just said, probably look at the instant solenoid kit because it'll make your life easy to install it. Now, that said, there are places where you need that adjustability. And, kind of on request, we will pull the vices apart and we'll pull out that spring. And in some cases, we've even added a new spring, making the vise like a normally open configuration. And what that lets you do is be able to dial in very precise numbers. Sometimes like a normally open configuration can make sense if you want to do like a bunch of vices through a rotary union on a trunnion and you want them to individually actuate. Like for instance, if you put 3 vices on a rotary union trunnion system, you're not realistically on a small rotary. You're not going to get 6 airlines with a rotary union. We make some of the smallest rotary unions on the market and they won't do 6 lines, but we can create solutions that will do enough lines to where each air vise only needs 1, to where we can swap the spring, make it a normally open configuration, and then actuate each one individually. So like there are answers there, but the long and short of it is if you just want to like go on the website and buy a thing, there is that lower threshold, which is on the spec sheets.
Okay, cool. Ethan Patain asked, what's the most creative, either high volume, clever, or otherwise neat use case you've seen with your products?
One thing that I will say is we don't see a lot. We have countless customers who they'll buy 1, 2, 3, however many spindle grippers, however many vices. I've seen purchases of 10, 15 vices at a time. And I just never hear from them again because they're just running stuff, right? They'll just run the product. And, we have some medical and aerospace companies, like they will buy a vice and a spindle gripper to run one part and they run it all year. And then, we never hear from them again because they have their own app Sky and so on and so forth. So I'm sure there's a ton of really cool stuff that we never get to see. And, we also do a bunch of turnkeys. And unfortunately, pretty much every one of those start with an NDA being sent via email to us. So, from what I can say, like there's a bunch of publicly posted videos of people using them. CJ Abram on Instagram is somebody who is just a brilliantly, very talented machinist. He's a better machinist than I will ever be, bar none. And he basically has been turning his brother into like a Williman using a couple of our spindle grippers. And it's just this crazy setup where, he goes and grabs the bars, loads them, unloads the finished parts. You can do some incredible stuff. We have some other turnkeys that we're working on where, I can't really say what the parts are, but there's multiple vices. You grab the stock from a location, machine the first stop, Then we have another vise, which actually serves as a part flipper that's on the side of the trunnion that grabs the component, flips it 180 degrees. Then we re-grab it with a spindle gripper, reorient it, put it back in the second vise, finish the part, and then it, slides out on a little system as a finished component. So, I mean, really, it's like the sky is the limit. And the cool thing is that you can just, if you can build one part, especially if you're willing to do, the work of getting multiple vices or a complex setup going, it makes it as easy to do, X parts as it was to do one. And how complicated that entire setup and process is really depends on the machine. Like, if you want to do something crazy and you just want to buy, a UMC 500 and throw a conveyor loading system on, you can machine weird, crazy parts all day long. You can integrate a part flip, and there's no complicated machinery at all. It's just like one or two spindle grippers, the CLS and the machine. And then if you want to do that on a 3-axis, it's another story where maybe you're putting a 4th axis on there. Maybe you're putting rotary trunnions. Maybe you're putting a part flipper. It really just depends what the base machine you're automating is and then what you're trying to do.
Okay. Let's see. Going towards the business side of the business, NYDLS30 asked, how's the business growth from Instagram versus other sources? So let's talk about advertising, because like you said,
sure, yeah.
You have been hitting us hard on Instagram. So
yeah,
how does that all work? Do you see, obviously you see enough of a return to continue to do it, but how has that whole process been?
Yeah, so as far as Instagram advertising goes, it's super effective. It's definitely the most effective channel that we started with. And then we've tried other channels. So Facebook advertising actually converts like just as well, if not better. But the community really isn't as in tune there, right? Like I think the Insta Machinist community, like personally, it's my favorite. There's a ton of cool content. It's always refreshing. Facebook honestly is just kind of polluted with junk. So it's difficult to find that same sense of community. And I guess Instagram's getting even worse and worse with it's being harder to actually see your followers and so on. But Instagram converts great. Facebook converts reasonably well. TikTok kind of sucks, but we post there anyways. And then, LinkedIn's just like too expensive. And for advertising, what, we found is, we've tried a whole bunch of different stuff and we looked at the cost per clicks and, what we found honestly is that like just showing the product and what it can do for people and just like a kind of casual voiceover and, try to add my face into things a little bit more. Just, putting a face to the name, letting everyone know we're real people. Like those have the better cost per clicks on the better conversion rates and so on and so forth. So, I think kind of owning that we're a small company and then just, eating whatever the advertising costs are. I mean, we probably spend on Gimbel Automation, I would say $5,000 or $6,000 a month advertising between Google Ads and Facebook. But the ads convert. And for a long time we were, by volume, our best selling product is our automatic tumble baskets by far. And that's a lot of it's just because like, you don't need a CNC machine. You just need a bead blaster. You just need to want to automate it, right? So you buy this little $400 doodad, you turn it on and all of a sudden you don't have to bead blast these tiny little parts. And it's another one of those things like we just developed it for ourselves because we have all these SLS 3D printed parts that make up the little pieces on the grippers. And in order to process them, we'd have talented people just sitting there getting paid way too much to be like blasting these things. So, we developed that as a product. We sold a ton of them and we were seeing a ton of sales when that was our only ad. Basically that were being driven from someone had a question or a problem or whatever, and they would call and, they would end up with me on the other line. And I would say, hey, have you heard of our spindle grippers? And then, all of a sudden we're doing like a full, $10,000-$15,000 turnkey for them. And I realized like, oh, wow, we need to like step up our advertising game. Cause like, this is really our core product focus. It's really where we make more money because, it's really where our unique value proposition is. And we do the coolest stuff. And the thing that we were primarily advertising at first, the tumble baskets, is really like an ancillary finishing product that kind of came about out of our own need.
Very cool. Yeah. No, I know you had reached out when I first mentioned you on the show like a few months ago, and it was before you had put your face on there. And I was like, yeah, I don't know if this is like a Chinese play for, US automation or what. Cause like I recognize the vise. Yeah. I was like, I don't recognize the spindle grippers. I've never seen those, but who knows? And then, you started putting your face on your page more and you reached out and we're like, no, we're here. We're in California.
Yeah. And I've been listening to the show since the beginning, like 2019 with Peyton with Brick Tactical.
Oh wow.
Yeah.
That's so funny.
I am like a super podcast junkie. So, if any of the guys or girls at work are here listening, I'm probably with those headphones on at the machine or in my office listening to some sort of podcast.
That's awesome. Let's see. Last question. TMC Makes asked, what % of your motivation to go to market was just proving to big automation that it doesn't have to be expensive or complex?
I just think I don't think I was trying to prove anything to anyone. It was just, I thought, hey, we spent 60 grand on this machine. Like, there's no way that it should cost twice that. Get some basic system implemented that just loads and unloads the same size component. And to be honest, like before we tried to build our own spindle grippers, like the very first thing is like, hey, does Shunk or THG or any competitors before they were competitors, do they have a solution? And the answer was like, even if you just wanted like a spindle gripper and a vise, you should talk to an apps engineer, and it becomes this $20,000 thing before they even do a turnkey, right? When it's just like a vise and a gripper. And then, by the way, you have to fall into this big list of constraints of the small type of machine that we do these for. And I was just like, kind of typical fashion, like that's so expensive, that's unreasonable. Let's just do it ourselves. And so many times that had been a bad decision, and we wasted money, building all fourth axes and building our own shrink fit machine that like doesn't work as well as a commercial one because we, every time you build something, like when you want to make an actual product, you end up with like 7 versions. So it ends up being pretty expensive, right? Like even if you want to build a spindle gripper, like the first one, it's going to cost you like 20 grand because you make a bajillion versions of the thing and then finally you figure it out. But, this was one of those things where, I was right. And what's even cooler is we were able to, introduce grippers to a part of the market that had never had them, right? I think like a huge part of the market doesn't have through air, through coolant. And this just wasn't even an option. I think there's a huge overlap with the part of the market that would want an automated solution that is able to run in the machine that isn't a $150,000, pallet-based, FANUC robot loading solution. So yeah, I wouldn't say we're trying to prove anything, but now, really our goal is just to help any shop automate stuff. I'm sure everyone who owns a shop, who runs a shop, at some point, regardless of if they've done it recently, has sat there and loaded parts. And like, it sucks. It's not fun. It's not like a good use of skills. It's just like a drain on you mentally, especially like if it parts like 2 or 3 minutes to where like you can't even do anything in between. And that's what we want to get rid of, is kind of like, letting people do the thing that they're good at, where they can make a difference in their company or whatever it is. So they don't have to just sit there, doing some kind of recurring task. If anything, I think that's what I'm trying to allow the shops that either, they have too many machines to be able to put a robot on every one, or, it just makes more financial sense to put one on every one, or it's just a better solution, even if the costs were the same. We're just trying to make good products, stand behind them, and go from there.
That's killer. Real quick, before we move on to shop news and new things, what are the limits of the spindle gripper? How heavy and big of a part can you move with this thing?
Yeah, that's another question that we have answers to. I'll tell you, typically what we recommend is like a 5 to 10 pound max part load. Now we have customers who have moved like 40-pound parts.
Whoa.
Yeah. The way I've seen people do it, and I'm by no means recommending this. Please don't do this unless you really know what you're doing and are willing to take the risk. But I've seen people where basically the gripper fingers, they'll custom make them and they like wrap around a big bar or something, right? And if they do that, then the gripping force limitation on the gripper no longer matters, because basically all that load is going straight into your spindle. So, you better trust your spindle bearings. I'll say that, like putting that much load on it, but it is technically possible. Now, I typically recommend like 5 or 10 pound parts. They really, really excel for parts that are like, a typical like, 6-inch cube machine part, or also super tiny parts. Like, knife makers love these things. Anywhere where you have something really small and intricate, you'd be shocked at the precision. I mean, little 50 thou holes will, on turnkeys, will custom print gripper fingers with little dowel pins that exactly locate into those holes, and we move the parts like that.
That's great. Yeah, I didn't realize that it was that powerful. 5 or 10 pounds is actually pretty significant. I just assumed you were limited to fairly small stuff.
Yeah, I mean, it depends on the part too, and what are the gripper fingers and so on and so forth. Like one of the big differentiators that we came up with when we put it on the market was, rather than just having, here's the gripper, figure out the fingers on your own, we just basically looked at like the gripper you'd put on the end of a FANUC, like robot for part tending, and just put that there. And then we took that one step further and put little rubber integrated pads under the little gripper fingers so that you can physically preload the part in the vise when the vise is closing. So you don't have to worry about whether or not your part is repeatable in Z. And then we put them in such an orientation to where you could basically do a round or a rectangular component without doing anything. And then, of course, if you have like a weird second op, then you sometimes get into like 3D printing or machining a special gripper jaw.
Yeah, that was one thing that struck me about your spindle gripper when I first saw it, was like, oh, it's nice that it's just like this grid of holes. You can kind of just do whatever you want.
Yeah, it's just a 1024 pattern. Yeah, and you just kind of screw the things wherever, and you can print your own fingers. It really is open to you at that point.
That's killer. Well, yeah, that brings us on to shop news and new things. What is going on new in your world?
Well, one of the new things, our conveyor loading system is just like really taking over production from everything else. We have a lot of part trays that are just kind of sitting there as we move things over to the UMC, and we're also trying to like make sure we don't overproduce, because that's one thing that's super easy to do when you have a button to push and you walk away, and each part takes 5 minutes. You can just let it run. It's very easy to make 700 of a part that you only need to make 50 of. One thing else that's new is, I said we had the power go out, so I'm at my kind of home office right now. So the power just shuts down, and everyone in the shop walked out, and we go and we saw the transformer like explode into fireworks and like 3 giant bangs with smoke in the air.
Oh boy.
Yeah. And then something else is we've just been really focused on expanding. So, I think the last time we talked was at that like Fusion DSI event. And, I think we were like 4 people then, and now we're at 9. So
holy cow.
Yeah, the growth has been just really hard to keep up with. And I hired a shop manager who is coincidentally also named Dylan to try to take things off my plate. And kind of at the same time as that, we've been, really focused on trying to put systems in place, standardized operating procedures with like just recorded videos of how to do different operations in our shop. We have a big kind of custom ERP system that works really well for us, with every single part and every single SKU that we sell is documented from the Fusion file to the SolidWorks file where it's designed. Just getting systems in place to make a business that's gotten so much bigger so fast operate the way I would want.
Okay. So speaking of the conveyor loading system, have you thought about going to like standard stock sizes so that you could run, one gripper worth of parts, one after the other versus 50 of one, 50 of the next?
So, yeah, I mean, one thing we've done with people with like doing turnkeys or trying to train them on the CLS has been, they'll say, I have a range of parts or a part family, right? And the question is like, okay, well, can we standardize the part size, the stock size, to be able to kind of nest a variety of parts within those confines? And really, in the conveyor loading system, you're only constraining the Y. So if you want to just like leave it set up, as long as that Y dimension of your stock is left the same and you're willing to like probe one extra cycle for the gripper probe length, you could use the same gripper configuration. Especially too, if you're using like somewhat decent precision stock, like you have a saw cutting person you trust, or you have water jet blanks or whatever, and at that point it's very possible to like within the travels of single gripper, not even 2 grippers, to be able to load and unload the same component. So like especially rectangular stuff, when we're processing a rectangular gripper part in-house, usually we'll oversize the stock by like, I don't know, 20, 30 thou. And then that leaves enough material in the Y dimension that we can grip it with the same gripper. So, I mean, it really is up to you, but I mean, at the same time, the grippers are so configurable with the little hole pattern, especially if you have like rectangular stock, it's super quick. And with the CLS, because there's just these fences that you kind of just arbitrarily move in and out, and then you just probe the center of them when it's on the inside position of the machine, it really doesn't matter. Like, the whole thing could, as long as it's, not, I mean, even if it were out of square, it would really self-correct. So, as long as, you're able to adjust it, I don't even know how much time you would save on the CLS. But that does make a ton of sense to, especially when you're still going on part trays.
How much throw does the spindle gripper have?
I would have to check. I know the vices, I believe, have like 10 millimeters total. The spindle grippers, I think it's like 150 thou. So it's a decent amount, but don't quote me on that. Look at the spec sheet.
Okay. Well, that brings me on to the last two questions I ask every guest every week. First up, what did you research this week?
Yeah. So I kind of jumped headfirst into things. So I've gotten really into scuba diving, and I have a mustache. So I went down the full face mask rabbit hole of trying to find one that fit perfectly. And I bought one and it didn't work right and it vibrated. So then I got a different one and returning the first one. So there's that. And then the other thing that I just started to research this week, when we had our power go out, I actually had my desk for my office. It wasn't here yet because we moved fairly recently. And it was in my hangar with my little airplane. And the backstory there is I had an emergency landing, an unplanned emergency landing in this, like tiny little 2-seater airplane that was, very much not fun. I saw my oil pressure spike and, I haven't flown since. And that was probably like a month ago. So
That's terrifying.
I went down to the hangar to, get all the stuff. And I was like, oh, I should really like investigate this and get an aircraft mechanic out here. And so I started investigating like, faulty sensors or what it could possibly be. And those have kind of eaten up my research over the last day or two.
Yikes. Well, I'm glad you're okay. I mean, that's pretty terrifying. Well, then the last question I ask every guest every week, what are the things you're working on to be a better person, leader, employer? None of us are perfect. What are you working on?
Yeah. So, I'm sure you've heard like a bunch of my kind of like scatterbrained operating style where I just will dive into something. And one thing that has been huge for me is just having more accountability. And I joined this thing, EO, which it's Entrepreneurs Organization. It's one of those, stupidly expensive organizations where you go with a group of other business owners. But, just having other people call me out on my BS, tell me like, what the real problem is versus what I think the problem is. And also look at, my business with, an analytical viewpoint has really, really helped me grow into a better business operator. I think I really started, especially way back in my like startup days early on. I've always had this kind of like very open, eager eyes, wanting to learn everything, wanting to do cool stuff. And I think really over the past year, I've started to grow into like an actually very good business person who has a passion for, mechanical stuff, rather than, a bad business person who tries to make it up by being very passionate and good at, mechanical engineering. And then kind of came along with that one thing that when I joined EO, I kept hearing people talk about was this EOS thing. I'm not sure. Have you heard of EOS?
It sounds vaguely familiar, but I definitely couldn't tell you what it is.
So, there's all those business books, I'm sure you've read a million of them. And I had read this book. It's called Traction, something Wickman. I think Gino Wickman.
Yes, Gino Wickman. Yeah, I've gotten through about half of it, I think.
Yeah.
I don't think I've ever finished it.
And that was a book that I read twice, and I didn't do any of the stuff inside of it. I'm sure everybody's done that. Read a self-help book or a business book and then just not do any of it. And then, when I started doing all the EO events, I heard people kept saying, oh yeah, we're using EOS. Like, what is your business operating system? So I'm like, okay, maybe we'll try this. And then, we added like structured meetings and all this stuff. And eventually we added like daily huddle calls that we have like every day at 8:30 in the morning. And now we have, it just really overhauled the business in a way that like, I feel, I'm working on the business, not in the business. I feel like everybody all the time, like knows what to do now, which is just like so night and day from even like 6 months ago. Just having a system where things are tracked, there's work orders going that are assigned to projects, and we know who's doing what has been just a game changer for me. And then kind of at the same time, I think with the automation stuff, I really came in with the goal of making it this like supplementary income. And early on, it was growing so fast, we were basically trying to get rid of our least profitable, most difficult clients. And I think that's one thing like people learn as they do more and more business is like, hey, like not every client is a good fit. Some clients actually suck and you need to fire them. And that's something that you usually learn probably a couple years in. And I had this idea like, we're not going to grow. We're just going to stay the same size. and then we're gonna, stay 4, 5, 6 people max, and do our thing. But then the automation stuff just kept coming. And I finally gave in and I said, oh, okay, like everybody's stressed. Everybody's like mad at me. And everyone knows I haven't hired enough people. And so all of a sudden then, I hire like 4 or 5 people. So, just being honest with myself and what the company needs, putting systems in place and really making it, a team and a group that's a lot more than just me, I think has been something that has been a lot of personal growth. And I think that's kind of affected the company being something that, has a lot bigger chance of a much bigger success than I could ever do alone.
How have you found people in a time that is, historically pretty hard to find people right now? So how have you managed?
Yeah. We're in LA, so it's a super dense area. And, I'll actually say like we didn't have a problem at all. And we have had problems before. So like recruiting during COVID was like really, really hard. And the more recently though, at least what we saw, we put up like a, shop hand position, assembly position. We were seeing like 200 applicants for, like $20, $25 an hour positions where it was just difficult to go through them all. So we were actually seeing just a ton of people. And I think part of that is just where we're located and, whatever the economic times might be when you're hiring. But I think part of it is, I tell people like, here are our benefits. We just have good benefits. We have great healthcare. We have a like 4% 401k match. We give like 12 days PTO every, Christmas here. Everyone gets like a 9-day block. That's just, additional PTO. I mean, it's just treating people well, being reasonable with your expectations, paying them decently and, just, being a decent person, right? If someone, needs to go to a doctor's or, understanding stuff comes up. I think if you do that stuff, like, and you pay a reasonable amount, like depending on where you're located and what the economic times are, right? There's all these ifs that have to line up, but I think it's not as difficult. But, at the same time, I also feel like business is kind of like a cascade that can either go better and better or more poorly and more poorly. And people, don't want to join a sinking ship. So like, when you're struggling, everything is harder. And when you're succeeding, everything is easier. And I've been on both sides of that. So, that's kind of my take right now, but I probably would have said something a lot less optimistic, 3 years ago in the midst of COVID when our revenue had dropped off a cliff.
Yeah, totally. I think that is an excellent lesson to end on. Thank you so much, Michael. I really appreciate you coming on. It's been kind of great to hear the backstory of everything. And I didn't realize that it has been, this quick that you've spun up such a wide variety of products. Like I just assumed that, he's been around for a while and just started marketing them or something, but super cool. And thank you so much for the time.
Yeah, thanks. And hopefully we don't bother you too much with our Instagram ads.
Not at all. One real quick, let people know where they can find you and where they can find your products.
So Instagram at Gimbel Automation, gimbelautomation.com. One thing, it's Gimbel, like the old like Macy's knockoff chain. It's, if you try to spell it another way, it'll probably redirect, but might not get there. We have a Facebook, Instagram, TikTok, but our website, you can also, reach out directly. We have a direct line on our website where you'll talk to a real person who will probably be me.
Awesome. Well, thank you so much. Thank you to all the Patreon members who make the show possible. New Patreon members, Levi and Ulunda Technic. Thank you guys for joining. Lets me send microphones to people like Michael so you have good audio. Thank you all for listening, and I will be back next week.